This is my Lab 3 report. So in my Lab 3, we're going to analyze different objects in space using GlowScript. We have a star orbiting a black hole of unknown mass located at the origin. We know that the star has a mass of 2 times 10 to the 30th kilograms. The position data of the star will be generated in the code, and the resulting trajectory will be with my GT email, which will be coded into the trajectory. So we will look at different equations in this lab. We will look at F net is equal to the change in P over the change in T. And that will make it so that dP dt is equal to F net. So looking at part 1 of the lab, we're going to use my GT email right here in line 11. We're going to edit in the mass of the star. We're going to do delta T. It's going to be 60 times 60 times 24, which is 86,400. And we're going to use the equations that we were looking at in the slide to calculate the dP dt, the F net perpendicular, and the F net parallel. When we run this code, it will show us the different forces and the F net, which is going to be that purple one, and the perpendicular and the parallel. And in part 2 of the lab, I entered in the mass that we had gathered, so it was going to be 1.2 times 10 to the 34th, which I got from part 1, and I ended up using a trial and error to get the ship speed. I had to calculate the different forces on the planet, which were F grav on the planet due to the black hole, the F gravity on the black hole and the planet due to the spaceship. Then I calculated the forces on the spaceship, which were F gravity on the spaceship due to the planet and F gravity of the spaceship due to the black hole. So this is what it ended up looking like. So my code is right here. I had to edit in the time, and this is what I got for the speed after I did a trial and error to make it so that it doesn't crash. So this is my code. I had to calculate all of that. After I calculated the net forces on each of the planet and the spaceship, I used Newton's second law and the position updated formula to get the initial velocity, which is shown in my code. And so basically when I run the program, it's gonna run through it. It takes like quite some time, but as I showed in the first part of it, it went through perfectly without crashing. So with the what does it mean question, the net force and the parallel and perpendicular components are different in this lab because we are measuring one component and the other component is inferred. Since we are measuring the dP over dt, we are inferring the net force from the measurement that we had got. This is why it is different, because the dP dt is measured while the net force is inferred based on what we had calculated. So with the what if, the initial velocity of the spaceship would have x and y values equal to each other to make it so that my spaceship would orbit the black hole. It would not crash into the black hole, nor would it crash into the planet by having the x values equal to the y values.